Oh, so cool. Piccolo is so cool. I want to have that recovery ability. If I have that, when I pick my opinion, cut my hand, I can have the new one. Oh, so cool. I miss that.
Hello, chat.
Oh, hello, sir.
Oh, I just found a very cool video.
What is that?
Check it out.
Oh, secret of how to grow your body like Wolverine. Oh,
Let's watch together.
I miss. Okay, let's watch together.
Yeah.
How to Grow Your Body Back Like the Wolverine, or the story about iPS cells and ES cells. iPS cells, short for induced pluripotent stem cells, and ES cells, short for embryonic stem cells, are methods that can make a new part of the body and replace the bad cells. For example, by differentiating ES cells into heart cells, culturing and transplanting them into heart disease patients, bad cells can be replaced. In this video, we'd like to talk about history, background of iPS cells, and the usage of iPS cells in everyday life. In 2012, Shinya Yamanaka and John Gordon were awarded Nobel Prize for Physiology or Medicine for the discovery of induced pluripotent stem cells, iPS cells. At that point, embryonic stem cells, ES cells, have already been discovered and researched much. ES cells also have pluripotency like iPS cells. So what's the difference between ES cells and iPS cells? Let's overview it through timeline. In 1998, 8 years before the discovery of iPS cells, James Thomson and John Gerhardt respectively start to isolate human embryonic stem cells and grow them in their laboratory. After that, a lot of research about ES cells have been done. And ES cell is expected to be used in cell replacement therapies and clinical trial. But ES cells have serious ethical issues because derivation of ES cells results from destruction of human early-stage embryo. In 2006, Shinya Yamanaka of Kyoto University in Japan reveals a way of making embryonic-like cells from adult cells. His team reprograms ordinary adult cells by inserting 4 key genes, forming induced pluripotent stem cells, or iPS cells. The process of making iPS cells raises no ethical issues because they are made from human adult cells, not from embryo. And after Yamanaka's research, the research about stem cells can be done easier. Yamanaka came upon with making iPS cells because of the famous sheep Dolly, the first artificial animal clone. She was born in 1997 by reprogramming of somatic cells back into the embryonic state. In an interview, Yamanaka said, "From that experiment, we learned that we should be able to convert somatic cells back into the embryonic state."
The usage of stem cells. There are many ways in which human stem cells can be used in research and the clinic. To sum up the usage, it can divide into 2 main usages. The first one, human stem cells are currently being used to test new drugs. New medications are tested for safety on differentiated cells generated from human pluripotent cell lines. To screen drugs effectively, the conditions must be identical when comparing different drugs. Therefore, scientists must be able to precisely control the differentiation of stem cells into the specific cell type on which drug will be tested. For some cells and tissues, current knowledge of the signals controlling differentiation falls short of being able to mimic this condition precisely to generate pure populations of differentiated cells for each drug being tested. The second one, the most important potential application of human stem cells is the generation of cells and tissues that could be used for cell-based therapies. Today, donated organs and tissues are often used to replace ailing or destroyed tissue. But the need for transplantable tissues and organs far outweighs the available supply. Stem cells, directed to differentiate it into specific cell types, offer the possibility of a renewable source of replacement cells and tissues to treat disease, including macular degeneration, spinal cord injury, stroke, burns, heart disease. For example, it may become possible to generate healthy heart muscle cells in the laboratory and then transplant those cells into patients with chronic heart disease. To conclude, pluripotent stem cells hold promise in the field of regenerative medicine because they can propagate indefinitely as well as give rise to every other cell type in the body, such as neurons, heart, pancreas, and liver cells. They represent a single source of cells that could be used to replace those lost to damage or disease. So, if you won't have an ability like Wolverine or Piccolo, why not try use this right after this video?
Are you sure? You want
Yes.
to do this?
Come, son. I want to
Are you
test.
sure?
Come.
I'm ready.
Yes. It's just a dream. Oh, what is this? Secret of how you grow body, like Wolverine.